One.
All right, good morning, good afternoon, or good evening, depending upon where you are in the world, and welcome to today's Security Boulevard webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. As always, we have a great event on tap, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will have the opportunity to access it later. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience, so if at any time during today's presentation you have a question for our speaker, please don't wait, don't hesitate, just use the question and answer tab on your interface there and submit your questions, and we'll try to get to as many as we can near the end of today's webinar. We also have a very interactive chat feature, so I do hope that I can get the audience engaged, and please feel free to send us your questions, comments, suggestions, whatever you want to share with us. We'll be more than happy to take it. And then finally, at the end of today's webinar, we are doing a drawing for 4 $25 Amazon gift cards. So please stick around. Hopefully you'll be one of our 4 lucky winners. All right, with that, let's go ahead and kick off today's webinar, which is the do's and don'ts of application security, or AppSec, for modern software development. Our speaker today is Sean Wright, who is Principal Application Security Engineer at Immersive Labs. Sean, thank you so much for joining me today. Really do appreciate it.
Thank you for having me.
All right, awesome. Well, I'm going to take myself off camera, put myself on mute, and I will see you back at the question and answer period.
Great, thank you very much. Again, big thank you for having me. It's an honor and pleasure to be here. And thank you for all the attendees for taking the time to join this talk, which hopefully will provide some useful insights into application security. So when I do these talks, I always like taking a step back and reflecting on what application security really is. And if you go look at the definition on Wikipedia, this is the definition there. Basically, boiling it down, it's a means of fixing and perhaps more importantly, preventing issues or security vulnerabilities in code. And you can even boil it down to even a simpler form, fixing and preventing bugs. At the end of the day, most security vulnerabilities are just a special type of bug. So how do we go about doing that? Well, before we go into that question, I think it's important that we take a step back again and reflect on how we used to do things and where the industry is going. So if you look at the way we traditionally developed applications, we built them from the ground up. So you had organizations that would build everything in-house. You didn't have this concept of going out and fetching different software from vendors and open source. Everything was traditionally built in-house and often frowned upon if you tried to get it from elsewhere. And you also had big monolithic releases. We're talking about a quarterly release or even a biannual release, maybe even more than that, like once an annual release. This meant things went out in big, massive bulks. So if you put reference to sort of something similar to like a cargo ship, where it's a big, massive chunk of change going out. And this is helpful from a security point of view because you now had the ability to factor in these big changes. You knew they were coming. You could plan accordingly. So yes, it was a lot of work to assess all of that functionality, but you knew it was coming. They weren't very often. So from that, you could actually allocate resources. So if you're talking about something like a quarterly release cycle, well, guess what? You can have a team dedicated 2 weeks, maybe even more, purely focused on assessing that release before it goes out. And similarly before, if everything's built in-house, you have stricter control around the software that's been built. And also importantly, visibility. You have much better control and visibility over that software being developed. So that's all great, but we've moved away from that. So if you have a look at the way software is developed today, it's very modular. Gone are the days where you would develop something completely from the ground up. In fact, you'd probably now be questioned or raise some eyebrows why you wouldn't go off and use some library, open source library, that's both freely available and widely available. And it's kind of why reinvent the wheel. So the way I view modern software is kind of gluing all these little modules together. So in the past, you try to build things from scratch, whereas now you kind of taking different modules and coding them so they're functioning together, they perform some function. And this is great. From a business point of view, this is fantastic. This means we can move a lot faster. We can get new features out to our customers quicker. And I'd even hazard to say that this is now absolutely necessary. As companies start becoming more and more competitive, we're going to have to deliver new functionality to customers faster and faster. You combine that with the notion of CI/CD, so continuous integration, continuous delivery. The notion that if everything's good, at the click of a button, I can release that software. So typically this would mean you do all your unit testing, your integration testing, maybe some sort of smoke testing. The point is it's all automated as much as possible, and it can be released really quickly. And this is fantastic because, again, you can get features out really quickly. And this means faster and faster and faster, which from a business point of view and customers is fantastic because you can get all these features really quickly. Now, from a security point of view, this can become a big problem. As things are going out very quickly, how do you make sure that those things going out quickly are secure? We don't have the option of allocating a security team a 2-week cycle to go test every single change, because these changes are sometimes going out on a weekly basis, daily basis, or even an hourly basis. So there's no way that a team can be doing that full time. And this is where we've got things like DevSecOps coming into play, where we have to start looking at the way we start dealing with security. We can't do it in the way in the past, where if you look at the timeline, you have the left, planning and design, on the right, your implementation, which I'll come to in a bit. We have to start moving away from the right and move towards the left. So this all starts falling into SDLC. How do we start embedding security into our SDLC? And to me, this is probably one of the most fundamental parts when we're talking about application security. Now more so than ever, this is becoming more and more important. So if you go look at the traditional type model where you've got your design at the beginning, you code something, it's tested, and then it's released. In the past, we typically did security checks and testing after the application was fully tested and before it was put into production. And that worked fine. I mean, as I said, you could allocate resources to do that when it was big monolithic releases. When we're doing that on a daily basis, that's no longer feasible. And then if you also have a look, well, many of the other things I've seen in terms of application security have been more focused or purely focused on developers. And that's great. I mean, don't get me wrong, developers are really important. Code is, after all, the fundamental part of the application, but is not the only part of the application. We have other people playing a role in that as well. So if you look at the application itself, you've got product managers, architects that are responsible for the design and having influence over the features and the requirements that then feed into the implementation. You have your testers that are responsible for testing that application that meets all the features and meets the requirements. And then lastly, you have the operations folk who are responsible for getting that application into production environment and making sure that it's running correctly. In my view, any one of these can be the weak link. You could have the world's most secure application from a coding perspective, but if it's put into an environment where the server is misconfigured, guess what? That application is now vulnerable. So this is why I view application security as the whole, not just developers. Then you're also looking at cost of fixing. So this graph is often touted on the internet. There has been some sort of question whether this existed or not, but I think the premise still is very much on par. This was largely from the IBM research, which has been called into question whether it even existed. But I still think that the principle behind this is relevant. So if you look at the SDLC, where you got design all the way on the left, so this is where you're starting to pick up requirements, figuring out what an application does, what new features do, and then production release all the way on the right. As we start developing and moving along that timeline, trying to fix things becomes more and more costly in terms of resources that have to be now included. So think about a production release. You not only have operations folk, you have testers now involved, you have your developers, and maybe even architects involved. So from a resource point of view, you have to start including more resources, which means more cost. There's also time. It's now going to take longer to fix versus, say, something like design. You're right at the beginning. So typically, you're probably talking about your product managers or your architects, maybe your developers at some point, at least maybe lead developers or something like that, having some influence in the design. And if it's caught early, you can easily adapt the design. It's a lot easier to adapt than a full-blown application that's been developed. So this is where the notion of fixing things and getting things earlier in the SDLC is important. And that's where you start hearing terms like shift left. So if you're looking at the SDLC, the left being design and requirements gathering. And this is why shifting left is so important. You also should start baking security into these things. So if you now look at the SDLC and shift left, every one of them should be touching security. And I think we're getting to a point where we need to stop mentioning the word security. And it should just be part of our SDLC. We shouldn't have to think about security. It should be so fundamental and baked into it that it's just part of it. Like, we don't call it, I don't know, the coding SDLC. Coding is very much part and parcel of the SDLC. So why should security be any different? Or why should testing be any different? So I think we need to get to a point where we have security and the tooling and the resources and the education fundamentally baked into the SDLC and enabling people to be able to do security easily, because that's another important point, is sometimes security is seen as a roadblock or a hindrance. We need to try to remove that. This is getting better. There are a lot of tools, especially modern frameworks, that are doing a fantastic job of this. In my past job, I went off and did a pen test for application. And the team doing it weren't very well versed on security. But guess what? I couldn't find anything like SQL injection and cross-site scripting vulnerabilities. I tried, I got frustrated. But the reason being is because they were using a framework that handled all of that for them, they didn't have to worry about that stuff. It was abstracted away from them. And the end result is they ended up with a pretty secure product. There were some business logic flaws, but those can be combated via periodic pen tests and design and occasional testing by an internal team as well. So what are some of the challenges that we face today? Oh, sorry, I had animation. Didn't realize to get a bit muddled up with the PDF. So what I had there is, at the moment, one of the things I think that actually, if we take a look, stand back and we look at common security flaws out there today. You have software vulnerabilities, you have hardware vulnerabilities, and then you have misconfigurations. This is a very simplistic view. There may be more, but if you really boil down most security flaws or incidents, they kind of come in these three flavors. And if you have a look at it from an application security point of view, you'll see that two of them are part of application security. You have your software and you have your misconfiguration. So this is why I believe security and application security is so important from a security point of view. Most vulnerabilities have, like if you go look at the CVE, which is the common vulnerability enumeration. So when you find a vulnerability, you can go off to an organization and get what's known as the CVE. It's basically a unique identifier for that vulnerability, and that's stored in what's called the National Vulnerability Database, the NVD. And if you go look at that list, most of those vulnerabilities, if you boil them down, come down to software vulnerabilities. So if we really want to make an impact on security, in my view, we've got to start looking at application security. And as I already touched on, we have the security versus functionality. Unfortunately, they kind of go against one another. We many times face that you implement some sort of security control that's going to come with an impact in terms of usability or functionality. Thankfully, this is getting better. And I think one of the things that is helping with this is security teams are getting more involved in the design and requirements gathering, so they can help bake security in without hindering the functionality or feature set, or too much, or even at all. And as well as trying to deliver faster, we also have to consider that. So the frameworks are allowing that, as I mentioned, where we can have these modern frameworks that cater for most of the security, preventing the most fundamental vulnerabilities, such as cross-site scripting and SQL injection. So developers can then just get focused and stuck in and work on developing features and applications rather than having to continuously worry about that. And then there's a whole tool sets that we are starting to see come about, where we can start embedding all these tools in. And some of them are really doing a really awesome job, where they're even getting integrated into things like developer IDEs. So they're making it a lot more developer friendly and at the coalface, so to speak. And as I mentioned, one of the other things that we have to face is the competition. So as organizations grow and more organizations come about, organizations are going to have to start competing with one another, or are competing with one another, and it's getting faster and faster and faster. So if you are still stuck on a waterfall model in some sectors, your organization may face quite significant issues, where you're going to have to start looking towards getting to more focusing on things like CI/CD to become more competitive, to get things out faster, to get things to your customers quicker. So that also brings in a problem from the security point of view. How do you do this quickly? To me, this is probably a bigger one. So going back to one of my first slides, where everything was built in-house, very rarely would you go out to an organization and get any sort of functionality associated with that organization. If we look now, as I mentioned, we're using more and more modules, more and more open source software. So that's a third party. It's not a commercial one, but it's still a third party. We're using cloud services. We are literally running our systems and services on an entirely different infrastructure owned by someone else, which we don't have any sort of control. And I wouldn't say visibility, because they do produce some sort of reports on that, but it's not like that physical hardware is running in a data center that we own. So we having to place more and more trust in different organizations. And as we've seen in the past, there have been some issues with that. And it's becoming a bigger and bigger thing. You'll hear a term now called supply chain vulnerabilities. And this is becoming a bigger and bigger thing. SolarWinds at the end of last year were probably the one that kind of really got this conversation into the high gear, where SolarWinds were compromised. SolarWinds is a network management software. So this affected several thousand customers. And when I say affected, they may have been directly or indirectly affected. The point being is the software, their build server was compromised. The software was installed on customers' sites. And some customers were directly affected, where the attackers used this software to gain access. But there were many indirectly affected customers. And I say indirectly because they still had to spend time doing audits and making sure that they weren't affected. So that's taking resources away from other parts of the business. Then a big thing for me as well is the way we do training and teaching around development and that. I think it is improving, but it is something that I still get really frustrated with. So back when I started, and this is a transcript of my degree, yeah, I did a Bachelor of Science in Computer Science. Now, this enabled me to go straight out of university into a job and start developing code for production systems. Not one course taught anything about SQL injection or cross-site scripting. In fact, I had the first course that had anything to do with security was Information Security and Ops Research, which was more mathematics around more encryption type things. I did a bachelor honors degree, which was postgrad, and even then I had another cryptographic course. So that wasn't really focused around secure development. And I did a network security course, and that briefly touched on security, secure development, but very briefly. So in reality, I did 4 years of university, not once covering what is cross-site scripting or SQL injection. But we'll still complain to developers who inject cross-site scripting or SQL injection, going, oh, you made a mistake, how could you do that? When in reality, they don't know anything about it. Or even worse, they don't know the impact of this. This is like another thing that gets to me. If you look at the de facto cross-site scripting vulnerability, script alert script, just show up alert box. What I, as a developer who knows nothing or very little about this, why would I be concerned about that? What impact would that be to my customer other than a mild annoyance? Instead, trying to show them something like injecting a BFOP, which is the browser exploitation framework. This is essentially a command and control, so you can take over the user's browser. That to me is a lot more impactful, because now that's starting to demonstrate why things like cross-site scripting are so dangerous. And I actually had this in my last company where a team thought cross-site scripting vulnerability wasn't that important or relevant, and they weren't too concerned about fixing it. I took the time, went through it, and showed them how an attacker could exploit that with something like beef. And it suddenly changed their perception of cross-site scripting and made them realize why it's so important to fix those things. This is another one. So if you have a look there, there's at least 5 from the OWASP Top 10 2003 that are in the current list. Now, OWASP Top 10 is a list of the top 10 vulnerability types or categories for that period that it was reviewed. So 2003 was the very first list, and 2017 is the current list. There's a new one coming out soon, I think this month, but this is what we have to go on. And if you have a look, at least half of the list from 2003, which is 18 years ago, if that's correct, we're still dealing with today. Things like cross-site scripting, why are we still dealing with this? In fact, I'd even say, I was actually recently looking at this list, and some in that list have actually gone away, not because we fixed the problem, they're just gone away because the technology's changed. Go look at buffer overflows. Buffer overflow is no longer an issue today because nothing's using technology that can be a problem. We haven't resolved buffer overflows. It's not like developers are now doing all this coding around preventing buffer overflows. Buffer overflows were a result of a lot of web-based applications using C-based CGI scripts. We've now moved to things like Java and Node and that kind of thing, where all of that's handled. So that's actually where we're also moving. So as I mentioned, a lot of the more modern frameworks are catering for things like cross-site scripting flaws or SQL injection flaws. So what I think is going to happen is as more organizations start leveraging more modern frameworks, a lot of those flaws will start going away, thankfully. But we'll still see things like the business logic flaws, so broken authentication, broken access control, because those are still very much logic flaws. The other thing that's a big concern for me is the components with known vulnerabilities. Overall, I think we, as a whole, generally don't do a great job of this. We've seen this with the likes of Equifax. So Equifax, I know this example probably gets beaten to death, but I still think it's very relevant because of the impact that it had. Back in 2017, Equifax had a vulnerable version of Apache Struts, which is a web-based framework, a Java web-based framework. And within that version they were running, it had a deserialization vulnerability. And this deserialization vulnerability basically allowed attackers to run code on the server. That's pretty bad. And the end result is the attackers managed to gain access to the server and then compromise the organization. The last estimate that I saw in terms of costs for that organization were around about $1.5 billion. That's billion with a B, dollars. That's a massive amount of money to spend on something. And if you actually boil it down, now I'm really simplifying it, but if you boil it down, you could have maybe fixed that vulnerability with a one-line change if you had the proper build management, the package or dependency management with appropriate scanning, a one-line change. And that, for me, really hits home about that. The other thing that we at Immersive Labs did earlier in the year is we had a report done for us by Osterman, and some of the results in there were pretty interesting. So one of them were 39% of the respondents, the security teams, felt they didn't have time to shift left. And I guess this is that continuous process, teams trying to get things out quicker and quicker and getting the security team to rubber stamp it before going out. They're not given time to actually build in automation to free them up. So combined with that, they also didn't see they had enough time to help the dev teams to get things quicker. And this is all resources. And it's probably a problem that's going to get worse until we start getting proper automation in place. The other big thing that came about was the vast majority released known code that had vulnerabilities in. And I think this is twofold. One is pressures from the business to get things out quicker. But I think that combined with my point previously with cross-site scripting, not having a good understanding in terms of what risks that brings to an organization. Think about a cross-site scripting vulnerability. If I'm a manager, I've got a critical feature that's going out. What's the worst going to happen? A customer's going to get an annoying alert box, and then several days later get shouted at, why is there a crypto miner on our site? So trying to get people to not only understand the ways to fix and prevent these vulnerabilities, but understanding the impact. To me, that's probably one of the most important things, is understanding the impact, understanding the why. Why should I be concerned about this? So I've briefly touched on this already. So SolarWinds last year, they had this vulnerability, and this was kind of the de facto supply chain that's often now spoken about. And as subsequently, there were a few others. But the important thing to realize about this is, as I mentioned, we're placing more and more trust in third-party companies. So, and that's not going to go away. We're going to start leveraging more SaaS-based solutions. So other companies that provide services, or other companies that provide software, not even companies, but organizations or individuals, in fact. So this is something that I don't want to jump on the whole supply chain wagon, but it is something that I think that's probably going to be one of the bigger things in our industry. if you think about it from an attacker point of view, why try to break down through the front door when you can get neatly inserted by an organization willingly? It's so easy to hide in amongst the sheer volume of the open source libraries and all of that being put out there. In fact, there's a library called Dash. Literally, the name of the library on the NPM is Dash, like the symbol Dash. I had a look yesterday. It was downloaded 15,000 times. The worrying thing about that, the library does absolutely nothing. It has no value. It has no functionality. So we have people blindly copying libraries and pulling them down. And this library is actually included in other libraries. So this is an area I think we're going to have to start focusing more on, and I don't know the answers of how to fix this yet. This is actually becoming somewhat less of an issue. I think we've finally seen some of the technical controls taking over and helping with this. So certainly last year, maybe the year 2019, this was more of an issue. You saw it like almost on a daily basis, where cloud-based databases, so you're talking about things like MongoDB or Elasticsearch or even S3 buckets, were all left open on the internet. I'm slowly seeing a lot less of this. And this is where I think having a lot more of the technical controls in place is going to help. So a lot of these, especially like S3, will now default to being private. And this is where we as professionals need to get involved, help with that design when we putting these features out to customers, to have security enabled by default and then have options to turn it off. As I mentioned, Equifax was the big one. And yeah, I've already covered that. I'm not going to go into too much detail around that. But yeah, again, showing the importance of keeping libraries up to date. So all the doom and gloom, kind of covered a few things that we could maybe do and start on. But what are the actual things that we can really start to do? Well, one of the things I do get asked periodically is, hey, Sean, I want to start application security for my organization. What do I do? Well, when you take a step back, you see all these things and you're like, oh my gosh, where do I even begin? It's like trying to climb a mountain. It's just a massive wall. One thing I would say, start focusing on the low-hanging fruits. Start focusing on the things that are going to gain you the most value. So the do's. So things like source code scanning. This is going to help you find things earlier on. It's not going to find everything, but it's certainly going to find things that are pretty immediately obvious. Do your homework on this. Some products are really expensive. They may or may not be worth the money. It's all going to depend on your organization. I'm not going to mention names, but there are free open source ones. There are commercial ones. Sometimes paying you get for what you pay for. Not all the time, but sometimes it is worth paying for the commercial ones. That's where you need to do your homework. DAST is really, really important if you have web-based applications. This is kind of the bit that you need before you release anything. So in the past, you probably have people manually pen testing. You can automate this to a degree. And please, 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 don't use this as a replacement for pen testing. Pen testing or penetration testing is absolutely vital. There are things that a DAS, which is a dynamic application scanner, so scanning the web application for vulnerabilities, it's not going to find mostly like things like access flaws. Automated tools not going to know that, hey, this user shouldn't have access to this. That's where a human needs to step in. It's also probably not going to be able to figure out business logic flaws because it doesn't have the intelligence to do that. And that's where you need things like periodic penetration tests. But certainly trying to find things like misconfiguration or missing security headers or cross-site scripting, that's where that tool is going to really help. And often that's more important than trying to find the business logic flaws. Don't get me wrong. Those flaws are really important. But if you look at it from a threat modeling point of view, those business logic flaws are likely where you're going to be individually targeted by attackers. So trying to figure out, targeted by specific attackers. The DAS will help find things that, I don't know, many people must probably heard, things like script kiddies, the ones that are scouring the internet to find people and targets. Even things like ransomware, they might use this to find potential victims. So things like that can help find that low-hanging fruit, shut down the door to less experienced or less advanced attackers. Dependency management. So as I mentioned, like we including more and more libraries in our software, and many organizations that I've seen and worked with haven't a good degree of knowledge of what dependencies are using and where. So if there's a vulnerable library that's coming out, it's normally a mad scrabble to go, okay, well, where are we using this? You should have all that information right up front. So if there's a vulnerable library, version X comes out, you can put it into the system and it'll immediately tell you which projects have it in place. And then you can go off and update those projects. Also, you may not be aware that there's a vulnerability in these libraries. So it gives you knowledge of which libraries you're using where and which of those libraries have known vulnerabilities. The other important one is knowledge and frameworks. So this is where you start getting your developers trained up in knowledge, be it webinars, online training platforms, even free resources. So OWASP, which is the Open Web Application Security Project, they have a whole wealth of documentation and knowledge in that. But there's commercial offerings such as ourselves, but there's also free ones out there. This, I think, has a big impact, probably one of the bigger impacts. Prevention is better than cure, as I say. And that also means you're enabling your resources to help prevent these, fix things, as well as integrate any sort of tooling, that kind of thing. And then lastly, frameworks. As I mentioned, more modern frameworks are handling a lot of the security out of the box. So becoming secure by default. This means you're going to free up time. You're going to have less worries around simpler things like cross-site scripting or SQL injection. And you can now have time spent having your developers focus on developing features and your security folk more focused on business type logic flaws, which may sometimes have a big impact. So covering some of the don'ts. So don't try to tackle everything at once. So if coming back to that slide with the mountain, don't try to take it all on at once. Try to break it up into chunks. So going to the previous slide, implement one tool at a time. Get that tool working. Make sure everyone's happy with it, knows how to use it, has input as to how to use it, how well it's working, any improvements that you can do. And then move on to the next thing. Trying to do everything at once, probably not going to succeed. Link to this, don't blow out blanky boxes. So all too often I'm seeing like, oh, there's this technology out there, it's going to solve all your problems, and it's going to solve all your problems, and it's the latest and greatest technology. Certainly not saying don't buy technology. When I mean don't buy technology there, I don't mean don't buy blinky boxes. So the latest and greatest types of that. Do your homework. Make sure what you are possibly going to buy is going to actually work for you. And make sure that you evaluate different alternatives as well. So don't pick the first thing that comes up. I generally try at least 2 or 3 and then see which one's the best. The us first them, so don't create the security and development teams. Obviously, they're 2 separate teams. But the thing that really gets to me is there's often the silo, it's a security team, the development team. At the end of the day, you're still working for the same company. You all still should have the same goals, the high level goals. Company succeeds. That you're part of that. So work together, help one another. So from a security point of view, understand some of the frustrations that developers and QA and operations folk are going through. And then from the those folks' side, understand some of the things that the security team has to go through. Believe it or not, security teams also have a lot of stress and issues that they have to deal with. So working together and helping one another is a way to address that. Checkbox exercises almost never work. So going with policy, like too often I've seen policies being put in or standards. Sometimes they are there and we can't do anything about it. Sometimes they are required by customers, and in that case, there's very little you can do about it. But I have seen times where policies and standards are just put in for the sake of it. Make sure it's relevant, make sure it's easy to digest and understand, and don't do it just for the sake of doing it. Make sure it actually has value and brings value. And then don't just rely on systems. So don't rely on technology solely. It's really important. You're going to need it, but make sure you have your humans involved as well. At the end of the day, humans are going to help configure that technology, maintain that technology, and interpret the results, or most of the results. And this is where you also want some of the humans involved in testing, so penetration testing. As said, work in chunks. Breaking things down means you're going to solve. You may solve fewer things, but you solve them rather than trying to solve everything, many things, and fail at solving all of them. I'd much rather succeed in 2 or 3 things than fail at everything. Related to technology, so too often I'm just as guilty of this at times, is you get a technology, you just put it in, and that's that. You just take it out of the box, install it, and expect it to do its thing. You're only really going to gain value out of it as much as you put in. So make sure that you configure and tweak things to your organization, your expectations. Another really useful thing is embrace the community. So the wider security community is very open and welcoming. There are many people that I've interacted with that aren't even don't have security roles, but they're still part of that community. Always willing to share knowledge and ideas and thoughts. So if you ever find yourself stuck, go out to the community, go to events such as your local OWASP chapter events or B-sides events, or even on Twitter. And then the other thing is use existing tooling. So don't try to reinvent the wheel. First, go off, see if there's a tool out there that can do it for you, and then leverage that tool. More often than not, they're actually free. So win-win. The updates and improves. So don't treat it as a one-off. It's a continuous thing. Technology moves. Things adapt and change. So make sure your training, your awareness, all that's kept up to date. Your tooling, your configuration, your software. It's all continuous. So you can't just go, right, I'm done, on to the next thing. It's a continual process. And automate where you can. So right at the beginning, as I mentioned, things are going to be coming faster and faster. Automation is going to be key. So automate the things that can be automated, because not everything can be automated. Automate the things that you generally find yourself doing more than once. Build in things into your SDLC. Already touched on this, education. So don't make it boring PowerPoint presentations where you stand up in front of the class. And as I say that, I realize this is exactly what I'm doing now. But have some sort of excitement. And this is where things like CTFs and hackathons, I think, can greatly help, is where you start having that collaboration and then engagement. And engagement is key. So it's not just someone standing, waffling away for a whole day or a week even. And that's another key to touch on, is many of these training things are great for a week, but if you go look at developers and their timelines and that people are busy, lives are busy, some of them may not have a week to dedicate to a full week for training. So having things that are in bite-sized chunks that can fit around their lives and their priorities certainly can help. Security champions are a group of people that are passionate about security, not necessarily full-time security people, but they help also bridge that gap between the security and the development or QA or ops teams. They help encourage security throughout the application teams and act as liaisons with security teams. So that can help break down some of those barriers. So yeah, hopefully this was informative and helpful for everyone. And I again, thank you for taking your time.
All right, great. Let's go ahead and get on into that question and answer period. We have plenty of time for questions, guys. If you have a question, please go ahead and send it on in, and I'm sure we'll have time for them. We've gotten some great questions in. So Sean, if you are ready, we'll go ahead and get started on those questions.
Absolutely.
All right, the first question is from Vasanta, who asks, what is the feature of software development nowadays? Coding is becoming less and less. Use tools to configure which generates code automatically with AI and ML. Is there any software development in the future?
I think we're always going to have software development. Until we can replace humans with AI and ML, actually replace humans with AI and ML, and I really don't look forward to that day.
No.
Humans are always still going to be there. Like at the end of the day, so AI and ML, especially more AI, maybe ML has got some future, but AI is still very much if else. So you can't really replace that logic or humans' logic with that. You're still going to need someone there. And even ML is probably not going to be able to do the really, the business logic type functionality. So if I do this and then go there, and then you need to do this nice drawing, or I don't know. But yeah.
All right, great. Nice to know that software development still has a future then.
Yeah, I don't see it going away anytime soon.
All right, great. I'm really happy about that myself. So. All right, next question is from Tilly. Tilly asks, what are the best two-factor, multi-factor authentication options? I understand texts are not secure, but could you elaborate as to why it's not?
Oh, I got to be careful with this one because this one's a bit contextual. So the reason why it's a bit contentious, and I get the different arguments. So text-based SMS, MFA, there are known flaws. It has been exploited in the past. So it's no longer hypothetical, hey, this has known vulnerabilities or weaknesses. It may be compromised. It has been compromised in the past. Based on that, as well as things like SIM swapping, and a lot of that SIM swapping comes down to trying to convince a human, which these attackers are very good at. I put it as something that I want to see the industry moving away from. Now, it is better than nothing. I will grant that. But I could say that about many things in the past. Like all the cryptographics algorithms are better than nothing. There is an argument that some people don't have access to later things like smartphones and that is a very valid argument. So there is that to still consider. What I think should happen is organizations should give users a choice. Starting off, hardware keys. So they are these things. These are great from usability point of view. I just plug it in, press a flashlight, done. To date, as far as I'm aware, Google have enforced all their employees to use that. Not once have any of them actually been successfully phished. So it has that benefit as well. So not just from a secure, preventing authentication via compromised password, but also helps things like phishing. So that's a great thing, but that has a cost associated with it. Then you go to push notifications, then SMS.
All right, great. Next question is from Keith, who asks, blockchain seems to provide increased data security, thus making apps more secure. What are your thoughts regarding that? And true, not immune to hacking, but decentralization gives it a better line of defense.
It is an interesting topic. So this is one of the things that I sometimes get frustrated with when terms just get like bounced on for companies' own benefits in terms of real marketing. So talking like blockchain and even now it becomes supply chain. But if you boil it down, I think they do have valid use cases. And I haven't seen anything from a secure application security like blockchain really solving a really big problem, but I think it's coming. And I think it has potential. So ignoring all the buzzword bingo, I think is what I've told it. It has potential, and it'll be interesting to see how it plays out.
You and me both. I'm interested in it also. It is a fascinating, but you're right. There's a lot of hype around it right now. So I'll have to see how it all falls out. All right, Tilly's got another question for you. What is the difference between pen testing and red teaming? And any examples of what you get out of both?
Yeah, so with a pen test, you have a defined scope. And that scope will keep you kind of in the narrows and saying you can do this and you can't do that. So it's basically focusing on different bits that you want to do. Red team, on the other hand, goes, there it is, have at it. So pen testing is a lot more focused and targeted, whereas red teaming is probably broader. But between those two, the pen testing, you might find more vulnerabilities, where the red team, you might actually get more relevant vulnerabilities. It's all depending on what you're looking for.
All right, great. We've gotten some really great questions, and I think we're going to be able to get to all of them if we just kind of keep forging ahead. But thank you to everybody who did submit questions and are still submitting questions. Magno just sent one in that says, between SAST, DAST, and SCA, which one of them do you suggest to start first, and why?
It's a toss-up between DAST and SCA. The reason why is SAST, which is scanning the source code, often produces a lot of false positives, and I've never really seen it like go, wow, this is great, this is fantastic, solved me on a lot of things. Whereas DAST and SCA, I've seen a lot of benefits out of them immediately. SAST involves a lot of efforts. DAST, I'd say right now, DAST is probably the one that you want to do if you haven't got anything in place, because it's going to find those low-hanging fruits. And this is probably what a lot of script kiddie type attackers would do. So probably for that reason, use DAST. But SCA is going to become more and more important as organizations use more and more libraries and modules and frameworks.
All right, great. Mike is asking, can you give more reference to the Dash library you mentioned? Has it been studied for security concern? If it is derelict, or did it really serve a purpose? And what do we do about OSS allowing almost unlimited linking of unknown libraries?
Yeah.
Back in that question.
So the Dash one, I don't know if we can share links out on that, but I'm more than willing to share.
We can go ahead and put that right up in the chat box.
Yeah, I'll try to see if I can find it. Where this came about was there was a news article that actually mentioned this library, and started just paying attention to it. To me, it's just crazy. Like, I have no idea how this library came about. Like, I don't know how someone would publish a library that does nothing without trying to, I don't know, get people to use it and then inject a payload or whatever. But having said that, it's got one version that's pretty old. It has only one version, and it's not been updated for a while. So I don't know what's up with it. Regardless, I still think it does point to a problem in the way that we consume libraries. As far as the OSS linking, this is why you need things like SCAs in place. It depends how stringent you want to be. Probably, you don't want to start filtering every single package, because you'll be there forever and it's not very good. You want to have tools that you can probably set up policies and start defining these policies and what they can and can't do. And have some sort of logic. This is an area that I think is going to be really interesting going forward, because we still don't have a good solution in place of how we're going to solve the whole library dependency management stuff. I'll put the link there. I'll put in the question. Sorry, I don't know where to put it, but there it is there. So that's the link to the package that I was talking about. So you can go have a look at that.
Tell you what, I'm gonna put it in the chat so everybody can see it here. There you go. I just put it in the chat, folks. So there's the link. I think we have time for one more question here before we close things out. Paul asks, in terms of qualified talent for AppSec roles, there's generally much more demand than supply. So what are a few tips organizations can look into for finding the right people for the right roles at the right time?
Yeah, I know there's a whole debate around, there is a cybersecurity shortage. There isn't. Certainly, I think in AppSec there is. When I've tried to hire people, there definitely been some difficulty in doing that. In terms of asking organizations, this is where things like security champions and that are going to help a lot. If you, like ultimately, the route I took into application security is I came from a developer background. Mm-hmm. I was always interested in security. I never had the opportunity. I got involved with a company that did security, and thankfully it worked out for me. I went from a developer into a security role. Now that has massive benefit for that organization. They're getting someone who probably knows a lot about the code, the systems, and that. So in terms of that, that's a really big win. So my advice there is organizations should start looking at getting those developers or those people on the engineering teams who are interested in security, getting them trained up, and then get them moved over to a full-time security role. Because they're probably the ones that are going to add a lot of value simply because of the amount of knowledge they already have, the internal knowledge, as well as you don't have to spend months trying to hunt for someone. Not always going to be the case, but I think that's one good way of trying to find the right people for the right roles and leveraging security champions. So they may have half-time development, half-time security.
All right. Great answer. All right, guys, we're about 3 minutes to the top of the hour. So unfortunately, that is all the time that we have for question and answer period. I think we got to all of the questions, but if we didn't, please know that the folks at Immersive will be getting a copy of all of the questions that came in, and I am sure that they'll be more than happy to follow up with you and get your question answered. Also, a quick reminder to the audience that today's event has been recorded. So if you missed any or all of the event, or if you just want to watch it again, you'll have the opportunity to do so. We will be sending out an email after this event that contains a link to access the webinar on demand. And the webinar is also going to be living on the Security Boulevard website. So you can always go look for it there. Just go to securityboulevard.com/webinars and look in the on-demand section. It should be right there waiting for you. All right, before we close things out, let's go ahead and do that drawing for the $425 Amazon gift cards. Our first winner today is Vasanta T. Congratulations, Vasanta. Our second winner today is Tilly D. Congratulations, Tilly. Our third winner today is Keith P. Congratulations, Keith. And our fourth and final winner today is Branislav S. Congratulations, Branislav. We'll be sending out your gift card information to you via email, so please check your inbox. And if you don't see anything there, please check your spam folder. Sean, what a great presentation. Thank you so much. I just enjoyed the entire thing. So much information in there. And judging from the number of questions we got from the audience, holy smokes, they got a lot out of it too. So thank you very much for that. I really do appreciate it, your time and your expertise.
Thank you for having me, and thank you for everyone attending. And those questions, they were amazing questions.
Great questions, yeah. I also want to thank the audience for joining me. This is Charlene O'Hanlon, and I am signing off. Have a great day, everybody, and please stay safe.
Thank you. Bye.